Hi guys, so today we are going to learn section 5.1 perpendiculars and bisectors. And again, I know this seems kind of all over the place. This unit is just comprised of many different sections from the book, okay? So a perpendicular bisector is a segment, and then I'm going to kind of put in a slash here, line or ray, because it could be any of those, that is perpendicular to a segment at its midpoint. And just a reminder, guys, the symbol for perpendicular is that upside down T. So on segment PQ here, in order to draw a perpendicular bisector, first we would find the midpoint. Let's just go ahead and call it M. And then we would draw a line that passes through it, creating a perfect 90-degree angle with segment PQ. So that line that we just drew is the perpendicular bisector. So let's put a point on it. Let's call it A. And then the way that we would write this is we would say AM is the perpendicular bisector of PQ. So just also think back to Unit 1 when I did that cheesy I dissect a frog comment, right? So just remember, whatever's second, just like that phrase, I dissect a frog, is what's getting cut in half. So you don't want AM to be second because that's not what's getting cut in half, okay? So that's the first term that we learned in this lesson. The second one is equidistant. So I'm going to go ahead and highlight these terms so they stand out in my notes. So we've got perpendicular bisector, and now we've got equidistant. Guys, equidistant is exactly what it sounds like. It's comprised of two parts, equi meaning equal, distant meaning distance. So if two things are equidistant, they're the same distance apart. So equidistant, a point that is the same distance from 2 points. So I want you to just think for a second, looking at this picture, although we are missing a letter here, let's just call this Q. Looking at these, which point is equidistant and what is it equidistant from? If you were just going to look at that for a second, what would you say? Well, hopefully your answer was that Q, because you can tell it's the same distance from A as it is from B because of these tick marks. So we would say that Q is equidistant from A and B. Okay, so Q is equidistant from A and B. All right, one more vocabulary term. Perpendicular bisector theorem. So we already learned about the perpendicular bisector. Now we're going to kind of take it further and talk about applying it. So this is kind of tricky. So I'm going to kind of put a star here to remind me that when I go to study for a quiz or a test, this is something that we definitely want to study. So here's what it says. It says, if a point is on a perpendicular bisector of a segment, then it is equidistant from the endpoints. Okay? So here's what that means. If you guys look at this diagram, we are given that AB is the perpendicular bisector of PQ. So remember that I dissect a frog. This is what's getting cut in half. So I find PQ and I cut it in half and I put tick marks to remind me of that. Likewise, since it's perpendicular, I can put my right angles. So I know for a fact that AB is the perpendicular bisector. Here's what this fancy, super confusingly worded phrase is trying to tell us. It's telling us it doesn't matter where. If I pick anywhere on this line and I put a point, then I can connect and make it equidistant from each of these endpoints. So I know for a fact that if I connected P to this blue point I just drew, it would be the same distance away from this other one. And likewise, guys, isn't point B on that perpendicular bisector, and it is also equidistant away. You know what, guys, I have to put 3 tick marks. I accidentally did 2 tick marks again, and it's not the same as those orange ones, okay? So I know for a fact that any point drawn, so guys, just to show you one more time, if I draw a point here and I connect it to each of these, whoa, I know for a fact that those red lines are going to be congruent as well. It only works, though, when you're working with a perpendicular bisector. Okay, so what I want you guys to do right now is I want you to practice drawing a perpendicular bisector of each of these. It obviously doesn't have to be perfect, but what I do need is I need you to label with markings, okay? I don't care if you draw letters, but I want to see like markings, like congruent marks or right angles, etc. So go ahead and pause the video and press play when you're ready to see the answers. Okay, now before you go marking anything, thinking you did something wrong, I want you to listen. I just drew them a little differently on purpose. I drew a line here as the perpendicular bisector. Here I drew a ray as the perpendicular bisector, and here I drew a segment. I just did that to show you that it doesn't have to be a line every time that's the perpendicular bisector, okay? But what I do need you guys to make sure of is that do you have tick marks and right angles at each of these? You don't have to have all 4 right angles, but you need to have at least 1, okay? If you have any questions, make a note and we'll go over it in class. Otherwise, we're going to move on to an algebraic example. Given AB is a perpendicular bisector of PQ. Guys, I cannot stress this enough. Labeling your picture is so key. A lot of people think that because this isn't a 2x plus 5 or an exact number or an expression, that this isn't information that can be marked. Because this is crucial information. AB is the perpendicular bisector of PQ. That means that I can put tick marks on PQ and I can put right angles at that intersection point. So that's huge. That's telling us a lot of information. So a lot of people pass that up and end up getting a wrong answer. Now angle ABP is 2x plus 5. ABP, I'm going to mark that 2x plus 5. BQ, that's this piece here, is 5y plus 8. And then PQ, this entire length, is 60. So now it wants me to solve for x and y. So the very first thing I'm going to do is I'm going to try and solve for x. I find x in the picture and I ask myself, what is this? Well, guys, this one is talking about the angle. Good thing I marked my right angle, because now that tells me that I can set 2x plus 5 equal to 90 degrees because we were given this perpendicular. I didn't assume it. It's because of that word perpendicular. So I subtract 5. 2x is equal to 85. Divide by 2, and x is equal to 42.5. Guys, please don't be afraid of decimals. I do think it's smart that you recheck your work and make sure you didn't make a mistake, but decimals are a friend, okay? They are fair game in any problem. So x is 42.5. Now I look for y. Now, a lot of people who don't label their pictures, they think they just can do it real equally, and they go, oh, 5y plus 8 equals 60. Well, that would be wrong because 60 is this entire piece. So that means each of these pieces is actually 30. So the correct equation is 5y plus 8 is equal to 30. Or you could have called the other one 5y plus 8, and you could have done 10y plus 16 is equal to 60. Both equations will get you to the right answer. I'm going to use this one, though, because they're smaller numbers, and that's easier for me to deal with. So 5y is equal to 22. Divide by 5, and I get y to be 4.4. So y is 4.4, and x is 42.5. All right, so if you have any questions or if that didn't make sense, play it again. Otherwise, we will totally go over it in class on Monday. So go ahead and flip it over. We have one more concept to talk about today, and that is the angle bisector theorem. So you guys already know what angle bisectors are. It's something that cuts an angle in half. And also, by the way, this is the second thing that I would suggest studying the most. This is another tricky one. That if a point is on an angle bisector, then it is equidistant from the two sides of the angle. So here's what that looks like visually, but actually, I'm sorry, first. Equidistant. Guys, I want to point something out and make sure that you guys know that when you see the word distance, that is implying a perpendicular. And I'm going to actually do a demonstration in class on Monday to make sure you guys understand this, but distance between something implies perpendicular because it's the fastest way to get there. Kind of like when you find the distance between 2 points, it's that straight line. Well, it's the same idea when it comes to perpendiculars. So, when it said that it was equidistant, that was implying that there's going to be a perpendicular here. So, CA bisects BCD. So that means these angles are congruent. Only because of that, I know that since A is on the bisector, so a point is on the bisector, so that's point A here. It is on the bisector. That means that I can drop a perpendicular to each ray of this angle, and I know for a fact that those two will be congruent. So because of that, I can guarantee that those two segments are congruent. Better yet, guys, this is making right triangles, which is where things can be tricky. So I'm going to do one more of these with you, and then you guys are going to do the remaining 2 drawings. So this says draw an angle bisector for each angle. So also, guys, just do one thing at a time. Don't read too much at once. It can get overwhelming. So draw an angle bisector. So I draw my ray. And guys, if you're drawing a bisector, make sure you put swoosh marks, okay? And then it says show that a point on the bisector, okay? A point on the bisector. Pick anywhere you want. I'm going to pick, I don't know, right here. Is equidistant. That implies a perpendicular from the sides. So I drop a perpendicular to each of these sides. That's a really, really bad. I am terrible at drawing this upside down. There we go. These two have to be equal, so I have to put those markings. Okay, go ahead and pause and draw these remaining 2 and press play when you're ready. Alright, so here are my drawings. Notice I have the right angle, the swoosh marks, and the tick marks on all of these pictures. This last one was super tough, for sure. Just kind of goofy looking. Alright, last problem together. I remember this problem specifically being on a quiz or a homework quiz, or both, and it being tough. So I definitely want to make sure that we do this one nice and slowly together. So AC bisects BAD. Okay, so I can put my swoosh mark. But guys, also, this is where this last theorem comes into play. If a point is on there, guys, and you draw a perpendicular, what has to be true about these two? They have to be congruent. That's what we just practiced above, okay? So again, look at everything I just marked from this one tiny little piece of information. I was able to put angle swoosh marks, I was able to put tick marks, and then I was able to double check those right angles. So then they tell me that BC is 5, and then they tell me that AC is 13. Well, first of all, if BC is 5, so is DC. And so that I can find right away, 5. And then it asks me for AB and AD, which is the tricky part. However, guys, we have a right triangle here. And you guys learned in chapter 1 that in a right triangle, we can always use the Pythagorean theorem to solve. C squared equals A squared plus B squared. So I'm going to do exactly that. Remember, the cross from the right angle is always your C value. So 13 squared equals 5 squared plus, let's just go ahead and call this x squared. So 169 is equal to 25 plus x squared. Subtract 25, you have 144 is equal to x squared. Now remember, you square root both sides. When you insert the square root, you have to account for the plus or minus. So this is plus or minus 12 equals x. However, we can't have negative side lengths, so we do actually just count the positive version. So AB is 12. And now, guys, these triangles have to be the same. If they fold over, they land on top of each other, because we'd end up doing the Pythag again with the same numbers. So it's 12.